Welcome to EC Academy. My name is Dr. Eric Chow. Today I would like to talk about the electrical engineering major. What is electrical engineering major and in today's college? First, let's look at this chart. No matter what engineering discipline, nowadays the core computing model is the most important. And then you need to be able to realize your computing model by using computer science skill, using programming language to model it, and then build your electrical system, control system, signal system, communication system, or any other application in different fields. So math is the king, computer science is the queen. Use the computing model to model your computing system. For electrical engineering discipline, it is to design electrical system. It includes the electronic system, communication system, and maybe also power system. And there are different design flow from system to gate level, to circuit level, to physical design level, to manufacturing. So there are many disciplines. Here I use the IC design flow as an example. They are different system or device design. And the electrical engineering can be divided into two parts, system and electrophysics. On the system side, it basically deals with signal and system. And the signal and system including computing system, signal processing, control, and communication. And on the electrical physics side, it basically deals with the circuit down to device, down to power, different electrical properties. So basically they are device, waves, power, optics, and many other fields, maybe plasma. There are several different things. So right here it is a branch for physics. And circuit design, IC design actually is from top to bottom. So actually it encompasses the whole system design to RTL design, to gate level design, to circuit level design, to layout design, to fabrication, to final packaging, and also to the device building such as physics, electronic physics, and also chemistry. So circuit design is coming from top to bottom, include every different fields. So electrical engineering really is to build a electronic system or electrical system using your information technology. So it includes the system for information and also electrophysics for the powers. And in the CS, CE, EE, CSE, EECS disciplines, they come from software application, firmware, to system, and to drivers, to system hardware, to PC board, to system, to IC, to subsystems, different levels. Computer science basically from instruction set level up to the application. Computer engineering from OS, networking, computer architecture down to the board. EE from the system design of the hardware down to the IC. And computer science and engineering sometimes mentioned about the CS and also CE. And EECS should come from the app down to the subsystems. So here give you the idea of these different disciplines, how are they divided. So from another aspect, electrophysics deal with the power and the signal, and it is analog signal. And EE system deal more with the digital signals. These signals are quantized and actually being able to fit into the computer. So basically electrophysics and the system, they divided by the power and information, two different branches. So electrical engineering, electrical and computer engineering, and electronic engineering sometimes are similar. And EE system means signal and system. And electrophysics means power, device, optics, and waves. And you need to learn the mathematical modeling as well. So you need to learn all of these in electrical engineering majors. Some of the majors are electronic engineering, and they may not learn too much about optics or waves. So it depends on the department. Every school have different curriculum. And in high school, you can prepare yourself for the EE major for robotics club, or maybe doing science club. And also you may learn AP physics, especially the electricity and magnetism. And also you need calculus, statistics. And these are the courses or club activity that can help you to prepare for EE major. In the college programming side, you need to learn basic programming skill and the university physics 1, 2, 3. And electrical engineering is like a shopping mall. So basically you learn core signal and system and circuit and systems. And then after that, you learn different technical field. So you have computer control, signal processing, communication, and wave, power, optics, and electronics. So basically, these are different fields you actually would like to major in. And there are many courses under each branches. So you need to pick the one that you are interested. And it is a shopping mall. So usually EE major, you need to find out your own interest. It is different from computer science major. Computer science major, there is a core CS discipline that you need to pick up. In EE, basically you learn the core courses, only very few. And then you need to take some elective courses and try to major in one of the branches. Sometimes the department will require you to pick 3 fields out of 8. And it depends on school. The curriculum can be very different. And in the math side, you need to learn calculus for engineering 1, 2. Sometimes they want you to take 3 or 4. And you need to learn linear algebra and discrete math. Sometimes the discrete math can be waived, and probability and statistics. For signal processing, you are recommended to take the random process as well. So take UC Berkeley as an example. You will need to take EE16A and B, and these two actually are focused on signal, circuit, and system. And you also need to take CS70, the discrete math. And in the robotic track, you need to take EE53, 54, 55. 55 can be replaced by CS70, random process and optimization modeling, and EE120, signal and system, EE123, digital signal processing, and then EE106, A and B, robotics. So UC Berkeley is a department that allows you to take whatever course you like. So after EE16A and B, the core courses, you are allowed to take any course that you like. It can be in the signal field, robotics, circuit, power, device, and optics. So basically go back to the core course that we talk about in the EE system and the electrical physics. Basically, they allow you to take whatever course you like. It is a all-you-can-eat buffet style. And in MIT, on the other hand, the 6.1 electrical engineering, it is different. It is one of the 5 different majors courses in MIT. It's a meal set type of the program. So basically, they design the required course for you, and you need to go from the introductory subject, foundational subject. So foundational subject is equivalent to the circuit and system and signal and system in EE16 AB in Berkeley. And after that, there are some required courses. You choose 3 of the subject. That means that you choose 3 fields to work on them. And then after that, there are some more advanced topic and some elective fields. Thank you. Bye now.